Hey there, imagine it's 3 a.m. Your phone is screaming on the nightstand. You pick it up, squinting through the light, and see the message every engineer dreams of avoiding. Production is down. You are at your laptop, staring at the dashboard that makes no sense. Your queue is red, your users are screaming, but your cluster is just sitting there. Everything is green in Kubernetes, but your business is dying. You have the horizontal pod autoscaler or HPA configured. You did everything the standard tutorials told you to do. But for some reason, while your Azure service bus is drowning in 50,000 stuck messages, your cluster is just sitting there, idle, doing absolutely nothing. Most engineers think they are safe because they use HPA. They think they have checked the scaling box. But today I'm going to show you why HPA is often just a false sense of security. We are going to deconstruct the lie and then we are going to fix it. Welcome to the KEDA masterclass. Before we break the system, I want you to understand exactly how I have built our laboratory today. There is no black box here. We are using standard Kubernetes building blocks so you can replicate things yourself. Look at this manifest. First, we have this config map. This is the brain of our chaos room. Inside, this is a simple fast API script. It's not complex. It just connects to an Azure service bus and on your command floods a queue called orders. So as you can see, it is expecting an environment variable connection string. So here we need to provide the connection string of our service bus, and in this service bus it is expecting a queue with this name orders. Very simple, right? And then it just displays this UI, and upon we click on generate button, it will just call this function which will insert some dummy messages into our Azure service bus. Very simple. You don't have to worry about this code at all. It's just my way of intuitively teaching and making it interesting. So I have just added some UI element to it so that we can mimic how load is coming to the service bus. That's all it is. Next, we have the deployment. This is where we run the generator code. Pay close attention to the environment variables here. We have something called SB connection string. We aren't hard coding secrets. We are injecting the connection string as an environment variable so the pod knows exactly where to aim its pressure. It will know exactly which service it has to connect with and look for the new messages. Finally, we have exposed this deployment through a load balancer service. This gives us the public IP address so we can open our chaos control panel in a browser. I'm a person who is particularly concerned about look and feel. Okay, so that's why I have created this laboratory. Otherwise, as you can see, this has nothing to do with KEDA as such. So this makes my class lively, and that's why you people love it. Yeah. It's time to apply and see what we have just discussed. So I'll just say kubectl apply -f. We are at the same location, so I'll just say 00 tab for auto completion and hit enter. So this will connect to my Kubernetes code and create these resources in the default namespace, as I have not specified any particular namespace. Yes, let me get the service. Okay, so it is creating the service, but external IP is not yet applied. Azure is taking its own time. Let's not disturb it. Okay, there we go. Here's the IP address. I'll just copy it and go to my browser. Hit enter. And there we go. Look at the UI. It is clean, it is neon, and it is dangerous. Think of our application like a busy pizza shop. You have one chef in the kitchen. How does a normal chef decide they need help? Usually, they look at how sweety they are. They look at the temperature of the oven. This is exactly how HPA works. HPA only looks at internal symptoms like CPU and RAM. But imagine this, a bus pulls up outside, 50 hungry people walk in. They aren't screaming, they are just standing there, placing their orders. There are now 50 order tickets hanging on the kitchen wall. Does the chef feel sweaty yet? No, he hasn't even started stretching the dough. Because the chef isn't hot yet. The manager, the HPA look at the kitchen, sees a guy standing still and decides we don't need to hire more staff. Because the manager is not looking at the correct metrics. Ideally, he should be looking at the number of orders that have been placed in the restaurant, right? But instead, he is looking at how busy the chef is. And if he is not busy enough right now, why to get external help? So what if 100 orders are in the queue? Right? That's how HP works. The customers wait, the queue grows to the moon, the business fails. But our beloved HP is still waiting for the symptom, which is how hot is the oven or how sweaty is the chef. But it is completely ignoring the cause, which is the tickets, number of tickets or number of orders that have been placed. This is the blind chef problem, and it is happening in your cluster every single day. Now let me show you this. So I can change this number to, let's say, 500, keep it 5000, whatever you feel like. And what this application does is when I'll click on send, it will inject those messages into the Azure service bus. Okay, queue. If I just refresh here, you can see 500 messages have been injected. If you do it like more times, maybe 500 more, let's say, send orders, it will again inject some dummy messages into this same queue. This is the working of our chaos room. It will just create an order and send to the queue. This is the first application. Now to process these orders, let's deploy another application, which is our lazy worker application. This is just a deployment whose only job is to take out the message from the service bus queue and process it. And by process, I do not mean anything complex. It will just print the message and basically clear the queue, right? It again connects to the same Azure service bus, obviously, yeah. And this is the pain point. We have got horizontal pod autoscaler here, which has got minimum replica of 1, maximum replica of 10. It can go up to 10 replica. And this is the matrix it is looking at, CPU utilization. We have kept it at 50%. So whenever the CPU utilization is above 50%, it will just spin up another pod until it reaches this limit of 10 pods, which is the maximum, right? That's how HPA works. And this is a trouble point as well. It will look at the current CPU utilization and it will simply ignore the number of messages that are piled up in the queue until the current application has got higher CPU utilization than 50%. It will not bother if 5 lakh messages are there in the queue or 5 messages. It will completely ignore the message count in the queue. Let me apply this as well. kubectl apply -f. Please ignore this error 01 and hit enter. Okay, so lazy worker is spinning up and it is running. Let's see if the queue count has started decreasing. Not yet. Okay, and now it's installed the necessary packages and there we go. Though application has got nothing to print, but if I see the queue count, it is gradually decreasing, meaning our messages are indeed getting processed by the lazy worker. Now let's get technical for a second. Why is HPA fundamentally the wrong tool for an event driven world? It comes down to 3 fatal flaws. First, it is reactive, not proactive. HP is a thermostat. It waits for the room to get hot before it kicks on the AC. But in a messaging system, the heat comes after the disaster has already started. We need a motion sensor, something that sees the crowd coming before they even open the door. Second, the lag. Kubernetes is slow to react. It only checks your pods every 15 to 30 seconds. By the time it realizes the CPU is high and actually starts a new pod, minutes have passed. Your traffic hits like a lightning bolt, but your scaling moves like a turtle. By the time help arrives, your apps have already crashed. Remember last time how many minutes you waited in a website? I just want to be realistic. Do we even wait for 30 40 seconds for after submitting something? We just want immediate results. And here, as you show, the pod itself took like 30 seconds to get started. So in the current system, first HPA will check for the existing CPU utilization. Then it will, as per the conditions we have described, it will create another replica. That replica will take some time to get started. It is causing a lot of lag in the system. Next, the IO blind spot. This is the most common trap. If your worker is waiting on the database or an API, it is busy, but it isn't using any CPU. HPA just looks at the 0% CPU and thinks he's doing nothing. Don't add more pods. Meanwhile, your queue is piling up with thousands of messages. HPA is literally blind to the work waiting in the queue because the pod isn't sweating yet. Let's prove it. Let's look at the current pods. So we have got lazy worker running, and let me go here, refresh. Okay, messages are reducing. I'm still watching the number of pods. Let's see. It is already 60 seconds. The chef is processing orders one by one very slowly, but because he's mostly waiting on the IO, the CPU is still sitting at 1% or 2%, and as a result, it is not creating new pods. Just 7 messages processed. It's just doing one by one, but no CPU load, and that's why there's no extra pods to help. And finally, there is some relief. So CPU utilization finally increased, and as a result, we see 2 extra workers to support this load. And now you will notice that queue count is decreasing slightly faster. I believe now you clearly understand what is the issue when you are using HPA in event driven architecture. Yes, even though there are thousands of orders in queue, it doesn't care that your processing time is now 3 hours, so it has to act faster. Instead, as far as the blind manager is concerned, the chef isn't sweaty, so the kitchen is fine. This is the HPA scam in full effect. And finally, it has considered to increase the pod counts. See, it has gone up to 10 pods now, and now we will get the real speed of processing the messages. Yeah, see, the speed is increased quite a lot, right? How we wanted it to behave is it should not take this long to create those extra pods. When it look at the queue count, it should increase the number of pods immediately. And that is quite a logical step to do. Also, I want you to understand this another issue with HPA. It cannot have minimum replica count to 0. Means even when there is no message in the queue, it has to run minimum 1 pod. That's like you are paying for zombie pods to sit there and stare at the walls all night long. When you know that during non-business hours there won't be any message, why you would want to run one extra application, right? Instead you will want to use your Kubernetes for some better purpose. But with HPA that's not possible. You minimum have to run one replica. Alright, I believe now clearly you got the issues with HPA. In the next lecture, we are going to perform a brain transplant. We are going to give this cluster eyes so it can see the tickets on the wall and scale before the first pizza even hits the oven. See you in the part 2. Take care. Hey there, welcome back. In the last lecture, we watched our pizza shop fail. We had 1000 orders, but our blind chef, the HPA, did absolutely nothing because he wasn't sweating yet. You saw the bottleneck. You felt the frustration. Now, I want you to imagine a different world. Imagine a manager who stands at the front door. The moment a bus pulls up, before a single customer even opens the mouth, the manager picks up a phone and says, "Get 10 more chefs in here now." I see the crowd coming. That smart manager is KEDA, Kubernetes Event Driven Autoscaling. By the end of this lecture, you are going to perform a brain transplant on your cluster. You are going to take a system that only feels heat and turn it into a system that can see the future. This is where you stop being a passenger and start being the driver of your infrastructure. Now, let's clear up a huge myth. KEDA does not replace the HPA. In fact, it makes the HPA better. By default, the HPA is like a manager who only looks at the kitchen thermometer. If the room isn't hot, he doesn't hire. KEDA is the upgrade. KEDA is the manager who look at the order book. KEDA stands in front of the HPA and says, stop looking at the thermometer. I am going to tell you exactly how many customers are waiting in line. KEDA provides the external metrics and the HPA provides the muscle to scale the pods. We aren't throwing away Kubernetes native power. We are just giving it much better source of information. You know what? We can't just talk about it. We need to install it and feel it. We are going to use Helm to bring KEDA into our cluster. Now, like me, if you are not having Helm installed in your system, then you can simply install it like this. This will get Helm installed in your system, and the confirmation could be just you type this command and you should have these options coming up confirming Helm is successfully installed. Now with this we are all set to install KEDA. I cannot stop from showing you the documents. So all we need to do is execute this. We just need to add the repository and just install the KEDA, right? So I'll just do it right in front of your eyes. Copy this command, go to your terminal, paste it. Okay, then just install it using this. So it will create its own namespace called KEDA and install the necessary Kubernetes objects inside it, right? Seems to be done. See how beautifully they have written KEDA. Cool. There are some creative people apart from me as well. Good. Clear my screen. kubectl -n KEDA get all. So these are some objects that have been created in order to support the beautiful features of KEDA. Just like that, the brain is alive. If we check the pods in the KEDA namespace, we see the operator and metric server. These are the components that are going to watch our Azure service bus and talk to the HPA for us. See, this is fun, right? We're not just learning KEDA, we are learning exactly how these enterprise applications work under the hood. I hope you are enjoying it and I hope you will not refrain from passing your feedback. How exactly you are feeling? Are you feeling more empowered to use Kubernetes than you were earlier? Or there is no difference? Be very candid. Containers are still not up. For the first time, we need to allow some more time to KEDA, right? Internal functioning has to come up. So it has to obviously pull down the images from, Docker Hub or somewhere and get them started, right? So that's where it takes little extra time. No problem at all. We can wait. Okay. Now that KEDA is installed, we need to give it instructions. We do this through a scaled object. So let me show you the next file. Let me grab the full screen for this. Look at this YAML. This is where you define your business logic. This is definition of a scaled object inside the default namespace, worker scaler. Using scale target ref, we point KEDA at our lazy worker. We are basically telling this is the application deployment name which you want to scale up or down as per the requirements. What are those requirements? We are yet to define, but this is your target. Minimum replica count can be 0 when you are using scaled object in KEDA. This is huge. If there are no orders, the kitchen is empty, we pay for nothing. $0. Yeah. Then we have triggers. This is very important. This is where we give it eyes. We give it the connection string to our Azure service bus. Using this, it can connect to the queue. So the type of trigger we are using is Azure service bus. Depending upon the queue that you are using, it can vary. So how many queues does it support? Let me quickly show you. Look at this. How many kinds of scalar KEDA supports? Any messaging queue that you might be aware of or you have ever worked in your life, you will most likely see it over here. Out of these, we are interested in Azure Service Bus, right? And this is how we landed up at this trigger. Now you understand, right? So type is Azure Service Bus, queue name is this, and then all other arguments. Based on the queue that you are using in your project, you might want to change this trigger accordingly. As per the documentation, the trigger type should be Azure-Service Bus. So we need to match it exactly in our manifest, right? I have mistakenly written it as Azure-Service. This hyphen is unnecessary, okay? So we need to get rid of it. This has to match, otherwise it will fail, okay? Also, please understand this. What we are using here is connection from environment. So we have already given the target lazy worker. So it will go inside the pod created by this deployment and take this environment variable from there. It must match exactly. So as you know that inside the lazy worker deployment, we have this environment variable SB connection string, right? So KEDA says, don't create environment variable for me separately. I'm happy to take it from your existing application directly, right? So that's the approach. And this message count, as you can understand, this is our rule. Every 5 tickets on the board equals to 1 new chef. So if it sees more than 5 messages, it will understand that there is a requirement for another replica of the pod. Okay, it's time to apply. I have to prove the point that I am not using HPA directly, so I'll just delete it. Otherwise you will think that okay, no, you had added HPA earlier and that's only doing the scaling. So I'll not give you that chance. I've removed the HPA. And as you understand now, there's no way HPA will scale up or down the pods, right? So if I just show you git PO, you can see there is just one pod running and there are 0 messages in the queue. Okay, and there's no way HPA will intervene. So I'll just apply this kubectl, apply this manifest using kubectl apply minus f 01 02. Okay, kubectl get all. This scaled object is a custom resource definition, right? It will not list by default. So for that reason, we have to explicitly say that I want to see the scaled object. And yes, it is here. Scaled object is there as well as it is in the ready state. That's a good sign. Let me show you a magic here. You remember we deleted the HPA. So ideally there should not be any HPA now. Let's see whether that's the reality. No, there is HPA. From where it has come back? Even though we didn't write an HPA manifest, KEDA created one for us. Look at the metrics section. It's watching our Azure Service Bus. That is such a good news. Okay, now let me clear my screen. We have got the scaled object and it is ready. But will it work? I don't know yet. So right now there is no pod of lazy worker running. Reason is we have defined the minimum replica count as 0. So because there is no message in the orders queue, there is no need to run any pod of lazy worker, right? There is no message to process. Why you need a worker then? Now we have got the scaled object to monitor the queue. What I want to do is insert 500 orders right now. Look at this. Messages are there. I'll be quick with this. I just want to show you how the pods increase. Immediately we are seeing 4 pods. See, pod even is not properly started and it has already created 4 pods. So we have given it a time of 15 seconds, right? As per our definition, we have given it time to do the polling every 15 seconds. So let's see if after 15 seconds, yes, it increased to 8. And as we talk, I think it should have increased even more because 15 seconds are gone, right? Yes. So it has increased to 12 now. You see, look at this timing. It's no way looking at the CPU right now because CPU consumption is very less. But you see, in order to process the messages, it has gone all way. KEDA wants to desperately reduce this queue count ASAP. So it's not trying to process orders one by one. Instead, it is going all way and trying to process it with the maximum workers capacity. And what's the maximum count up to which it will go? It will go up to 20, right? So this is kind of a safety cap we have to keep. Otherwise, it might increase it to like 5,000, right? And you do not want to get into situation like that because your all other applications running on Kubernetes cluster will suffer in that case. So that's the thing. Now the Kubernetes pods are running and application is also ready. So queue count should start getting reduced. And see, it is not decreasing one by one anymore because there are multiple instances of our application running in parallel to process these orders. Now we do not have one chef working anymore to make all the pizzas, right? We have got 20 chefs. So let me refresh and see how the message count looks like now. Look at this. See, that's the benefit. Now you notice how fast the queue is reducing. Now, obviously, before you point it out, yes, I did little cheating here. I increased the maximum replica count to 20 this time to make it faster, and in HPA it was only 10. Yes, because I want KEDA to look even better, right? But you got the point that it is increasing at rapid speed without looking at the CPU or memory utilization. It is just looking at the orders and it knows that there is more demand and it is simply spinning up applications to process that load. Okay, now I see count is reduced to 0. But will that mean that immediately these pods will be reduced to 0? Will it happen like all of a sudden? No, because we have specified a cooldown period which is 60 seconds. So it will not immediately scale back to 0. Who knows? Because the system has just processed 500 orders. There are a lot of workers who are warm. They'll still wait for more orders to come before going down to 0. You do not want to immediately close your restaurant after serving a big order, right? Since the workers are ready, you want to wait for more orders. And now 1 minute is passed and you see all of the pods are going down in one shot because there are no messages coming. Let's wait for its termination and there we go. You see we are back to 0 worker pod because there is no message to process in the queue. How cool is that? I'm sure you are already loving KEDA and believe me, it is market standard. If you are building an event driven architecture and you are not using KEDA, you are missing a lot, my friend. Now our demo worked perfectly using the environment variable from the pod. So I never had to define this connection string directly inside the scaled object. But I want to stop you right there. What we just did is a stage 1 success. It works, but we can make it architecturally better. We are going to improve this by decoupling the worker from the manager for 3 critical reasons. Least privilege. Your pod needs to process messages, but KEDA only needs to peek at the queue length. Separate credentials means a smaller security footprint. Next, scalability. If you have 10 different microservices watching the same bus, you don't want to copy paste environment logic 10 times. You create one passport, trigger auth for everyone. And lastly, independence. If the pod is crashing or cold starting, KEDA should not be dependent on the pod's environments to find its key. A direct line to the secrets keeps the brain alive even if the muscle is struggling. So I have refactored this version into this third file. What we have just done is created a secret which is containing the connection string. Then we have created this trigger authentication, another Kubernetes object which is holding this secret. So it is reading for us. And now scaled objects just have to reference this trigger authentication object to grab the authentication information. This is such a small change, but it helps you a lot when you are handling multiple microservices in your event driven architectures using KEDA. Yeah, let's apply this kubectl apply -f03 and here is our scaled object. And as we did before, let me push some messages here. There are 50 messages in our order queue. With this updated system, let's see whether it is working fine or no. So this is the scaled object. Let me describe. I want to teach you little troubleshooting also because even with KEDA we will need that, right? Okay, so if I describe it, it says deactivated. This is earlier because it had processed all the messages, so it will spin down it to 0. And now because it is finding the messages again, it is changing from 0 to 1 and accordingly it will go further, right? Let's take a look at the HPA also. Describe HPA. Why I'm showing all these places? Because when you will be in trouble, you'll need this. Yeah. So it seems to be doing its job, and as a result, if I just show you the pods, we have got 8 pods, right? 1, 2, 3, 4. No, 12 pods almost, right? It is working. So let's give some time and let me see if queue count has started reducing. Not yet, because application inside the worker is not yet ready. And there we go. The count has started decreasing, and I'm sure within a minute it will be reduced to 0. So that's the beauty of KEDA. All right, my dear friends, we have come a long way from standard HPA, moving from a system that was idling blindly to a production ready, secure, and event driven engine using Azure Service Bus. While we have built a rock solid foundation here, KEDA supports dozens of other triggers that I encourage you to explore in their documentation to fit your specific needs. I hope this lecture have given you the confidence and the architectural why to say you are now truly production ready with KEDA. Well, that's it for now. Take good care of yourself. Thank you.